Okay, let's try to address a situation which is technically often appearing. So we have seen a possibility to do like optimization by using Freecad and so on, and in the end we can also visualize it by using ParaView. But what we have visualized is simply not useful because it's not a CAD design. So it's more like a question of how can I create a part out of the stuff that I see in the ParaView. So let me try to visualize that. In order to do so, we need to do an optimization problem. Okay, let's try to open the Freecad, and I'm doing a part, or I can do a part design. Okay, so I'm going to the part design and create a new body, and in this new body I can do a sketch. Of course, it's asking me a plane. I'm just choosing a plane, whatever it is, and I'm trying to do something. Let's, I don't know, maybe do something like that. Okay, so then I'm going to path, right? Let's make it a bit thicker, maybe something like that. Okay, and maybe why not to think this part has a pocket here, and on this pocket I'm going to put a pin in order to fix it. So that means I'm going to create a sketch here. So the dimensions are not really that important, it just actually has the purpose of being an example. So let me put it here and then make a pocket. Right, so that's a nice pocket, and then I visualize that we have, I don't know, maybe like a pin there, which is somehow, it has to be fixed. So this dimension should not change. The optimization should not change this. So I'm gonna think like this is a pin, so I'm gonna fix these walls here, and then we will have somewhere else, maybe here or here, a force acting. So technically that's it with the part design that we need to do. So we are going to do now in FEM, because for optimization we need to do an analysis and then use it in this macro that we did it before. So in order to do so, I'm going to use an analysis, and so I can do the mesh first, but doesn't matter actually the stuff. So let me delete that one and do the mesh. Oh, I have too many stuff, so I'm going to delete all of them. So first let me do the mesh and like make something really coarse. Okay, and then do the analysis. For the analysis I need to have the material. It is again not so important. I'm using like steel, which is 210 gigapascal for the Young's modulus, and for the Poisson ratio it's 0.3. So and then I'm going to use for this one some boundary conditions. So as you know, we have two different boundary conditions. One is the Dirichlet boundary condition, which is the displacement that's given. So we can either say constraint fixed, so that means the displacement is 0, or I can use the constraint displacement, right? So I can say the displacement is given here. So if I click on that one, so I need to choose a surface, right? This is the surface. I can have even like more surfaces. So this surface and also this surface and this surface, they all are fixed. Okay, so I'm just using fixed. I can also say it's free and the displacement 0. Technically the same. It just made a little bit of a like easy method of saying fixed. Why not use it? There are also like rotations, but we don't care about the rotations because I mean, if you fix the whole surface, it cannot rotate as well. So this is technically for more reduced order stuff like the beams or something like, but we don't have that. We have 3-dimensional continuum body. So what we have are the displacements x, y, and z, nothing more than that. And we already have given for these internal surfaces of the pin that they are fixed. So I also need to have a force, and the force is here on this one, right? A constraint force. So for example, think that we have, maybe let's this one, a force here, and this has the direction. I choose this line, this direction, so it's like a shearing force here. So of course I need to give it like a something, maybe 1000 Newton. This is the load, this is in Newton. That means the total amount of the force is on the surface is 1000 Newton. So each of these small arrows are actually like the force distribution. It means the constant force divided by this area. So in this program you can only give like the force per area, so it's like a constant. You cannot have more technical stuff than that, but for many cases that's enough. So why not to have it now, the FEM done it, do it again, right? So such that it has a nice color. So I can even try to make it a bit finer. So I don't know exactly the dimensions. I'm gonna start with 6. All right, so let's make it 4. Yeah, it looks better. So let's make it 2. Of course, if I just put more elements, it will take some more time, but I want to have a nice optimization result. This is why I'm trying to get smaller. So if I say okay, now I can go to the solver and I can write input file, no mesh object defined in the analysis. Oh, okay, because I think this mesh is now outside, because first I did the mesh and then the analysis. So actually it doesn't understand that this mesh depends on the analysis. That's fun. It's weird, but I'm going to put it inside, and now the calculus is outside, so I'm going to put it inside. All right, so everything is now inside of the analysis. I don't know if it's really necessary, and if I say so, okay, now it's running. So I just wrote the I don't want to write it here, by the way. I just want to write it in somewhere else because I already have different stuff. I don't want to get them mixed. This is the topology optimization 6. As you see, I'm trying a bit. So now inside the topology optimization 6, I need to have the input file. We can, by the way, this is the direct problem, right? So we are defining the direct problem, then going to use the macro in order to do this iteration for optimization. So, but I can also run the calculus once, right, in order to see how it looks like. So by the way, just have a look. So because I have now used a lot of elements, so it takes some time, like 6 seconds, 7 seconds to do so. And let me have a look in the results as well. So I don't want to see, I see too many stuff, so I just go back to the model and then try to get rid of this body. So I just use space, putting on space. Space is like making it active and like deactive. I mean, active and deactive means like something like in order to just get out of the vision, so it's still there. So now if I go to the if I now go to the displacement, because it was already, I have double clicked that before, so I need to go to task. I can say close and then do the double click. Okay, so because it was already, the task was there, so I tried to double click that and said, what are you trying to do? So the displacement magnitude I can show, and you see the maximum displacement is only 5 micrometer, because I'm using millimeter, or I mean Freecad thinks that I'm using millimeter. Freecad thinks that I'm using megapascal as the material constant, so the maximum displacement is really small. So why is that so? Because the force that we have used is small. Okay, for the optimization it doesn't matter technically, as long as we try to make it less weight. So because we are more interested in the distribution of the stress, not the quantity of stress. If I don't use the maximum threshold, so it doesn't matter. So that's why I don't care technically about the load itself. But I mean, if you just do something more realistic, you can try to opt in a better way. So let me now try to use the macro for this sense, right? And the macro is the Beso Freecad graphic user interface. If I execute, then I see the graphic user interface. Now I use the analysis file from the topology optimization 6. That's what I saved it. And I'm not using a stress limit because the stresses are not realistic. The displacement is really too small in the sense. And what I'm interested is like the mass core ratio. I'm not so greedy, technically speaking. I don't want to weight too much, so this is why I'm saying 70% is good enough. Now I click on that one, only click it once, because technically speaking the computer tries to run once the direct problem, and we have just seen it. It took like 8 seconds, so actually it looks like it is frozen, right? It's giving me no mentioning at all, but no, it's not. So it is solving it once. There was only one iteration, 8 seconds. So if you like think of, I don't know, 100 iterations, it may take some time. So this is like the good part of doing computational engineering, right? So you can always have an excuse to make a coffee break and say, you know what, so my computer is running, so I cannot do anything else than that. So this is now 3 iterations. So actually it's doing iterations in order to reach the 70% goal mass ratio. So the starting of the mass is something like 80, so that means 70% will be right 55 or so on, right? So that means it will go up to 55. In 5 iterations it came back to the 75, so maybe it will take like 20 or so. And energy density mean, again, the number is small, we don't care technically speaking about the real number, but it is getting higher surely. Why? Because it is like less material will make more stress distribution. We can wait until the end, but we don't have to, because in each iteration it is writing out a VTK file, which is a paraview file, and then try to have a look in that. So let me see in the topology optimization 6, right? There are a bunch of files, so it's actually all merged together, so I can select them all by paraview. And if I say apply, then you can see here the first 11 iterations, right? In some time it will be more, but I will not see it here because at the moment that I opened it, it is like 11 iterations. So I can have a look how it looks like, and in the 11th iteration, so it looks like this. So technically speaking, yeah, I mean it's like a bit expected, right? So I'm putting the force here, so that means here it is red. Red means 1, and 1 means like we are keeping the elements there. That means 1. So don't remove these elements. Makes sense. And also the pin, right? So what we are putting here, because I fixed these boundaries, it's also like don't remove any elements there. I did not fix this face, but it is still suggesting me don't delete the elements there. Why? Because technically speaking the stresses are high there, and the rest is like this is what we want to understand. So actually I don't need these outer parts. That's what it is telling me. I can again use, by the way, let me have a look in Freecad. You see now we have iteration number 17. There's the other one, iteration number 20. So it's saying it's not responding, but actually just wait, because it is responding. So it thinks that it's not responding, but actually it is doing something in the background, and it's not iteration number 20. Okay, let me go back to the paraview. It is still iteration 11, because at the moment when I opened the files it was the case. So I can, of course, I can just say delete and open again, right? That's for sure. I can also try to say reload files in order to ask the paraview, just have a look again, maybe there's something new. And you can say reload existing files, which is not the case, because actually we want to have the newer files as well. So then the paraview scans again and finds out, oh, there are some new ones, and now it's up to the 24. Maybe it's still running, but this is already looking far better, right? So we can have a better visualization if we use this threshold. So this is one of the filters that we have here, which is called threshold. So I can use this one and let it show me only something which is 0.5 up to 1. Everything else will be discarded. I mean, it will not be shown. They are there, but it's not going to be shown. So I can use solid color. Maybe it's a bit easier to see, and that's somehow like the optimized stuff. So it looks quite okay. It looks quite correct, right? So let me see if it's finalized, by the way. See, it's finalized. Like after 24, maybe there's only 25, but it's not changing anymore. So it's finalized. I can try to reload the files again, and that's it. We have 25, but this is technically the same. So it looks like this. There may be, of course, some like difficulties about, okay, this one is not shown here. It's because of the threshold. I can even like put higher threshold. A lot of stuff will not be shown, maybe. right? Okay, it's still shown. I can also put lower threshold and try to force it to show me a bit more. That's not changing a lot. So the distribution is like, the change from the 1 to 0 is like quite quick. So as an engineer, of course, I would say I will not leave this element out, right? So I will still keep that one in. So now we can try to understand it better by looking into that. So I can try to use clip here and I can cut it. But if I do it, so I don't want to see the color. If I do it, so it is cutting like, you know, like a real nice cutter. So it's not actually showing me the elements, but I want to see the elements. The one way of doing it is like here on the left bottom. See, there's a bunch of different stuff that I can change here on this. Let me make it a bit larger. On this filter. So this clip which I have chosen here is a filter. So in this filter I can use the crinkle clip. That means show me the inside surfaces as well. So I can say surface with edge, then it's a bit even more easier to see. See, then actually we have the threshold, and on top of the threshold I'm using the clip. So that means inside it is not deleting any elements at all. So that's what the optimization algorithm is telling me. Of course I can change this one, you know, I can see apply, and I can see here how it looks like as well. So I don't care about the clip now, it's just for visualization. Now my understanding is like, okay, I can see what it is, but I want to use this as the basis of the CAD design, right? So I want to see this in Freecad, not in ParaView. So one way of doing it is like, you can go to this filters, there's a lot of filter, and look, by the way, I have chosen the threshold, right? I click the threshold, it's chosen, and then I go to the filters, and on one of the filter is where is that? It's supposed to be something like extracting the surface. So the threshold is somehow like not showing me some of the information and showing me only a part of the information. So what I see from the threshold, what I see on screen, I want to extract surface. So that means the ParaView will go really like surface to surface and create something. So I'm going to say apply and create something. I don't want to see this solid color again. Something which is looking exactly the same as the threshold, right? There is no difference between that one, let me get it away, and that one. But from the topological point of view, there is a difference, because threshold still has the information of the missing elements. I can change the minimum maximum here, I will see less or more, but the extract surface doesn't have this. It has only the information that I have seen in the threshold. Now I can do, now I have selected the extract surface, right? This is not selected. Now I can go to the filters again and then do something which is called triangulate. So the name is a little bit like maybe funny, because we have used triangulation or discretization in the FEM jargon, which is like dividing in small elements. But there's also another world who is using the same approach, again like discretizing the space, but not for doing numerical analysis as we do it, but something else. So which is called like graphics, animation, or even used in 3D printing. So this is like the how to describe a surface, is like describe the surface by using triangles on the surface. So this is why it is called triangulate. If I choose it and say apply, so you will see nothing, right? So again, showing me the element states, but technically speaking, it's exactly the same. But from the topological point of view, no, this extracted surfaces has a clear definition, which can be exported as a file. So that was my case. So I wanted to use the threshold, I mean what I see on the surface. I created new surfaces, so I discarded everything what I haven't seen, and technically speaking, from the extracted surfaces I now define the surface as by using the triangulation, and which is called a mesh, by the way, as well. And again, not for numerical analysis, but for representing the topology which is built by the surfaces. And now I can use this triangulated surface definition, if you like, which is just a surface, not interior. It is nothing inside. Okay, now I can try to export this data or save this data. Right, so now I'm saving the data, which triangulate has been chosen. I said save the data, and now it is giving me like bunch of different possibilities. These are all topology, right? These are all the surfaces and so on. What I'm going to use is STL. STL is more or less like a standard way of doing it. So I'm going to say the new or optimized part or new part. I'm using a binary, so it's a bit smaller, and for Freecad it's important. Now I go back to Freecad. I don't need them. Now I'm going back to Freecad and to make a new stuff. Okay, I just opened a new new project or a new document. Okay, and in this new document I'm going to use something, a new workbench that we have never used, a mesh design. You see, now the word mesh is not used for FEM anymore. It is technically speaking what people use for describing surfaces. And now inside this mesh I can of course import a mesh, and this is what we have saved as data as new part STL. I can import, as you see, all mesh files, and these are all topology descriptions. There are many. The most prominent one is STL. So I'm using this one, and voila, now we have in Freecad this topology that this part of the threshold that we have visualized in Freecad in ParaView. So it is still a mesh. Okay, it's still a kind of a surface that we have here, and it is somehow not really useful. But what we can do is, like, if I select a new part, we can try to do some or a lot of different stuff. So for example, we have analyze, you can evaluate and repair if there are some problems, and you can also like smooth, right? So I can try to smooth it. You see, I mean, I have just selected, I can redo it, so I can always do undo, by the way. Look, so undo, so I just undoing the smoothing operation. So again, I need to, if I just choose mesh, you don't see it here, but if I select the mesh that I want to change and go and then choose the smooth, now there are like different methods, right? And I don't know which one is doing what, but what we can do is, like, we can use it and see what they do, and if I like it, and what it does is like smoothing the whole surfaces here has been smoothed. Technically speaking, it's a really good idea to do it, but you have to be careful, right? Because of the smoothing operations, some part of the surface where I was actually bringing the force has been lost. Let me smooth again. See, I mean, it's getting better and better. But if I do it like I can even try to do the other one, right? If I do it like too excessively, I just lose the part which I wanted to have actually. So that means, like, I need to take care of like, of course, these parts that I want to keep. So technically speaking, this is not the CAD itself. Of course, I need to use this as a basis in order to do a CAD on top of that, because it's simply speaking a surface. So you need to either to try to convert it to body, which is difficult, or you can use this, because now it's in Freecad, you can just use it in order to build on top of that, like, because you can see now you can try to use the other stuff and then try to match the lines and then do a new CAD design. It's easier than looking in ParaView and trying to mimic it.